In this video, we're going to look at 10.4, use inscribed angles and polygons. So the first thing we need to kind of figure out is what is an inscribed angle. So as you can see here in this picture, here is an inscribed angle, and it is talking about this angle right here. So the formal definition of an inscribed angle states, an inscribed angle is an angle whose vertex, here is the vertex, is on the circle and whose sides contains chords. So it's the angle created by these rays, but inside they are chords. Now, the next thing we have to know is it says the intercepted arc. So you can see this is labeled in red on the picture. It says the arc that lies in the interior of the inscribed angle and has endpoints on the angle is called the intercepted arc. The intercepted arc. So you can see in the picture, it goes from here to here, and from across from that angle opposite, that is the intercepted arc. So that leads us to theorem 10.7, which is called measure of an inscribed angle theorem. Now you will use this one a lot, and it's actually an easy theorem to remember. So if you can look at the picture here, we have ADB, so here is ADB, that is the inscribed angle, and you have an arc AB that's being intercepted. And the theorem just says this, the inscribed angle is 1/2 the measure of its intercepted arc. So for example, if this is 50 degrees, then this will be 25 degrees, or vice versa. If that's 25, then that arc will be 50. Now, there's 3 cases of where this theorem can happen. So, case 1, C is the center of the side of an inscribed angle. So that's okay, that would be the angle there, C's the center. C is inside the angle, so we have this angle here, you can see C is inside. And you can also have case 3, where C is on the outside of the inscribed angle. So it can be smaller than 180, it can be bigger than 180, it can be less than. So let's go ahead and look at the examples here. It says, number 1, find the indicated measure of circle P. Find the measure of angle S. Here is angle S. Now, if you'll look across from angle S, you will see that this intercepted arc is 60 degrees. So the measure of S is 1/2 of 60 degrees. So S is going to be 30 degrees. Then it asks us to find the measure of arc, RQ. So if you find arc, RQ, so I'm going to clean the picture up. Here is RQ. Now, RQ has to be what's going on, like what is RQ being intercepted by, or what's going on here. So we know this is 60, and we have no way of knowing RQ. It's not being intercepted. But what I do know is this right here is a diameter. So this whole thing that I'm doing in red is 180 degrees. So now, if I look across from this 37, that is going to double and give me a 74 degrees. So if that's 74 and that's the blue piece, then I can calculate what's left over of that 180 degrees. So I can say 180 subtract 74 degrees, and that is going to give me 106 degrees. So now that we have knowledge of intercepted arcs, we can use that to solve more complex problems. Okay, let's look at number 2. Find the measure of arc HJ and the measure of angle HGJ. So let's first focus on HJ. Here is HJ. Now, it is actually being intercepted here by this 39, which is the inscribed angle. So if that is 39, I double it, this one out here will be 78 degrees. So the measure of arc HJ is 78 degrees. Now it is asking me to find the angle HGJ, so this angle right here. And if you look, it is also intercepting the same arc. So that angle would be half of 78. So that is going to be 39 degrees. Now the question states, what do you notice about those two angles? What do you notice about this angle and this angle? Well, I hope that you notice that they are congruent. They are congruent. So that leads us actually to our next theorem, theorem 10.8. It says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So I want you to look at this picture right here. We have arc AB, and we have this angle here, and we have this angle here. They are said to be intercepting the same arc. Therefore, they are congruent. So ADB is going to be congruent to ACB. So now let's look at the last examples here on the front page. This is going to be using theorem 10.7 and 10.8. Question 3. Name two pairs of congruent angles in the figure. Name two pairs of congruent angles in the figure. So the first thing I'm going to look at is I'm going to look at this angle and this angle because they are intercepting arc SR. So we can say that angle SPR is congruent to angle. So we have SPR. So we can say that that is RQS. Now, switching to this angle and this angle, they are intercepting that arc. So I can now say for this one, PSQ is congruent to QRP because they are intercepting the same arc. Now, question 4. It says find the measure of GHJ. Find the measure of GHJ. Well, across from that is 100 degrees. So using theorem 10.7, we take half of that. That is going to be 50 degrees. Question 5, find the measure of arc CD. That is opposite of 40. Therefore, we double it. So that's going to be 80 degrees. And last, question 6. Find the measure of angle RTS. RTS. So please note that RTS is intercepting the arc RS, but so is this angle here. Therefore, the measure of RTS is 31 degrees.